Venus is covered by clouds. The surface cannot be seen from the Earth, but using radar echoes, we can then map the surface of Venus.
Long before NASA's Magellan mission to Venus, the Russians had sent successful missions to Venus. However, for decades, the Russian government refused to circulate the findings and photos from its Venus missions. But all that has changed, as for the first time, Russia's classified images of terrifying discoveries on Venus have been leaked. The Soviet Union's Nero 1, Nero 2, and Nero 3 spacecraft to Venus were part of a series of ambitious and pioneering missions to explore the mysterious second planet from the Sun. These probes were designed to perform flybys, atmospheric entry, and landing on the surface of Venus, which is known for its extreme conditions of high temperature, pressure, and corrosive clouds. The Nero spacecraft were also the first to carry medallions bearing the coat of arms of the Soviet Union, symbolizing the pride and achievement of the Soviet space program. Nero 1 was launched on February 12, 1961, as the second spacecraft of the Venera Program 1. It was also known as Venera 1 or 1VA number 2. Its mission was to fly past Venus and transmit data about its magnetic field, radiation environment, and atmosphere. It was the first spacecraft to use a solar wind detector and a cosmic ray telescope. Unfortunately, Nero 1 suffered a communications failure shortly after launch and stopped sending signals on February 17th. It flew past Venus on May 19th at a distance of less than 100,000 kilometers or 62,000 miles, but no data was returned. It became the first man-made object to fly by another planet. Nero 2 launched on November 16, 1965, as the first spacecraft of the Venera 3 MV series. It was also known as Venera 3 or 3 MV3 number 1. Its mission was to land on the surface of Venus and transmit data about its temperature, pressure, and chemical composition. It was the first spacecraft to carry a radio communication system, scientific instruments, electrical power sources, and a pennant with the Soviet emblem inside a spherical landing capsule. Unfortunately, Nero 2 also lost contact with Earth before reaching Venus. It entered the atmosphere of Venus on March 1, 1966, and presumably crashed on the surface, making it the first man-made object to enter and impact another planet. Nero 3 was launched on November 12, 1965, as the fourth spacecraft of the Venera 3 MV series. It was also known as Venera 2 or 3 MV4 number 4. Its mission was to fly past Venus and transmit data about its atmosphere and surface features using a spectrometer, a magnetometer, a photometer, and a television system. It was the first spacecraft to attempt to take pictures of another planet. Unfortunately, the Soviet Union couldn't catch a break. Nero 3 also encountered technical problems during its flight and stopped sending signals after passing Venus on February 27, 1966. It flew past Venus at a distance of about 24,000 kilometers or 15,000 miles, but no data or images were returned. The Nero spacecraft was part of a long and challenging quest to unveil the secrets of Venus. Despite their failures, they demonstrated the courage and innovation of the Soviet space program in exploring new frontiers in space. They paved the way for later successful missions that revealed more details about our sister planet. The Nero spacecraft remained silent witnesses to humanity's curiosity and aspiration in the solar system. The Venera 4 mission, launched on June 12, 1967, was the first human-made object to enter another planet's atmosphere. It's an extraordinary success. It transmitted data back to Earth for a total of 93 minutes, giving insights into Venus's atmospheric composition, including the discovery that it was primarily carbon dioxide. Unfortunately, the capsule was crushed by immense pressure before it could reach the surface, but not before giving humanity its first taste of interplanetary exploration. Venera 5 and 6. Both Venera 5 and 6 were designed to analyze Venus's atmosphere, launched in January 1969. The thrill continued as they successfully delivered vital information about the temperature, pressure, and composition of Venus's atmosphere. However, like Venera 4, they were also destroyed by the intense pressures of Venus's atmosphere. Still, the data they sent back was instrumental in understanding our mysterious neighboring planet. Both Venera 5 and 6 were primarily atmospheric probes. Their main mission was to understand the composition and structure of the Venusian atmosphere. One of the most significant revelations was the confirmation that the Venusian atmosphere was primarily composed of carbon dioxide, with minute traces of water vapor and other compounds. This dense atmosphere, with over 90% carbon dioxide, began painting a clearer picture of the planet's greenhouse effect, a phenomenon that later became crucial in understanding the potential dangers of excessive CO2 on Earth. Venera 5 and 6 also delivered fascinating insights into the atmospheric pressure and temperature of Venus. As the probes descended through the atmosphere, they reported back the increasing temperatures and pressures. Both probes showed that the atmospheric pressure near the surface of Venus was far higher than that at sea level on Earth. In fact, the probes transmitted data until they were crushed by the intense pressure, which was around 18 to 20 times the Earth's sea level pressure. This was a significant finding, allowing scientists to understand just how hostile and extreme Venus's surface conditions truly were. Another exciting aspect of the data returned by the Soviet Union's Venera 5 and 6 mission was the vertical profiling of the Venusian atmosphere. As the spacecraft descended through the atmosphere, they transmitted data about different layers, giving scientists an understanding of how temperature, pressure, and composition varied with altitude. This helped in understanding not only the structure of Venus's atmosphere, but also offered clues about its meteorology and circulation. But that is not all. The data from Venera 5 and 6 also gave valuable information about the cloud layers of Venus. The probes reported on the sulfuric acid clouds and the thick haze that shrouded the planet, which later became a defining feature of Venus. The clouds, combined with the planet's slow rotation, play a role in its mysterious weather systems. While Venera 5 and 6 were not able to provide a comprehensive analysis of Venusian weather, they were crucial in the initial identification of its unique atmospheric features. The data from Venera 5 and 6 was not just vital for understanding Venus, but also had broader implications. For one, it gave scientists crucial information about the greenhouse effect, a topic that has become increasingly relevant on Earth. Moreover, by understanding the extreme conditions of Venus, scientists could better theorize about the potential range of conditions on exoplanets in other star systems. Venera 7, launched on August 17, 1970, however, would set a record when it became the first spacecraft to successfully land on another planet and transmit data back to Earth. Despite initially landing on its side, the probe righted itself and continued to transmit valuable information for 23 minutes, marking a new era in space exploration. Venera 8. The success of Venera 7 was followed by Venera 8, launched on March 27, 1972. It provided crucial data on sunlight levels at the Venusian surface and detailed atmospheric analysis. Despite the hostile conditions, Venera 8 functioned for a remarkable 50 minutes on the Venusian surface, continuing the Soviet Union's legacy of success. Venera 9-12. These 4 missions, spanning from 1975 to 1978, added even more excitement to the exploration of Venus. Venera 9 provided the first-ever images of the Venusian surface, a feat that was absolutely breathtaking at the time. The subsequent missions, Venera 10, 11, and 12, provided additional images and vital data on Venus's geology, atmosphere, and clouds. However, some of these missions faced failures, including lens cap malfunctions and loss of communication, which limited the data retrieved but did not dampen the enthusiasm for what was achieved. Venera 9 sent back the very first black and white images of the Venusian surface on October 22, 1975. The images revealed a rocky, uneven terrain with flat slabs of rock that appeared to be shaped by volcanic or tectonic activity. Venera 10, landing a few days later, provided additional images that showcased a similarly rocky landscape, adding to the intrigue of the planet's geological history. These 2 probes then confirmed earlier data about the Venusian atmosphere, being primarily composed of carbon dioxide with thick sulfuric acid clouds. Moreover, they helped understand how temperature and pressure vary across different layers, with Venera 9 recording a surface temperature of 485 degrees Celsius or 905 degrees Fahrenheit, and a pressure 90 times that of Earth at sea level. Venera 11 and 12, launched in September 1978, were intended to provide a deeper understanding of the Venusian atmosphere and surface, and did they deliver? One of the most intriguing findings from Venera 11 and 12 was about the twilight phenomenon on Venus. The probes showed that the twilight on Venus lasts longer than on Earth, caused by the thick atmosphere scattering sunlight. This scattering gives the sky a diffused illumination, even when the sun is below the horizon. These missions also provided the first evidence of lightning and thunder on Venus. The data suggested that Venusian lightning is different from Earth's in terms of its frequency and properties. This discovery gave credence to the theory that Venus has active weather systems, primarily influenced by its thick atmosphere and slow rotation. And while Venera 11 and 12 did not return as iconic images as their predecessors, they carried instruments to analyze the surface material. They detected elements like chlorine, bromine, and possibly iodine, elements uncommon on Earth's surface in significant amounts. The presence of these elements hinted at geological processes distinct from those on Earth. The images and data from these missions, especially from Venera 9 and 10, provided evidence for volcanic activity on Venus. The terrain's flat rocks and pancake-like structures suggested that the surface was shaped by lava flows. The discovery of certain elements also pointed toward volcanic outgassing as a key process. The insights into lightning, thunder, and the twilight phenomenon added layers to our understanding of Venus's atmosphere. It wasn't just a dense hot cloud of carbon dioxide, it was dynamic, with active weather patterns and interactions with the planet's surface and solar radiation. These missions' data was invaluable for scientists seeking to understand planetary evolution and dynamics. By comparing the processes on Venus with those on Earth, scientists could theorize about planetary development, climate systems, and the potential life-supporting conditions on other planets. The difficulties faced in transmitting data from these missions, especially in the thick atmosphere and extreme conditions, paved the way for advancements in spacecraft design and communication systems. The challenges underscored the importance of resilient technology in space exploration. Venera 13 launched on October 30, 1981. And for the first time in human history, Venera 13 sent back color images of Venus's surface. The stunning images generated lots of questions. How did this Venusian landscape form? What volcanic and tectonic tales were these rocks silently narrating? It was like receiving a postcard from an alien world, giving us tantalizing glimpses into its life story. Now, you'd think sending images from a planet notorious for crushing pressures and furnace-like temperatures would be achievement enough, but Venera 13 delivered even more. It did something no other mission had done before by taking a soil sample from Venus and analyzing it. The probe was equipped with a drilling arm, and it drilled right into the Venusian surface, analyzing the soil and sending back data that had scientists jumping in excitement. The soil composition, revealing traces of various minerals and elements, was yet another clue to the planet's geological history. Imagine holding a handful of sand from a distant beach. That's how profound this moment was for planetary science. Venera 13's sound recordings added another layer to this cosmic symphony. Amidst the backdrop of Venus's howling winds and the eerie silence of its desolation, the probe captured the sounds of Venus. These weren't just noises, they were the whispers of a planet, the ambient soundtrack of an alien world. For anyone who has ever dreamt of stepping onto another planet, Venera 13's sound recordings were an immersive experience into the world of Venus. And while previous missions had given us insights into Venus's extreme temperatures, Venera 13 reconfirmed them with its detailed readings. A scorching 457 degrees Celsius or 855 degrees Fahrenheit was recorded, with pressures that could flatten a submarine. Every data point emphasized just how hostile and enigmatic this planet was. Venus wasn't just Earth's twin, it was its fiery, wild counterpart, and Venera 13 was our trusted envoy navigating its extremes. Venera 13's suite of instruments didn't stop there. Its gamma-ray spectrometer, looking at cosmic rays, added to the existing understanding of both Venus and the cosmic environment around it. Additionally, with its seismometers, for a fleeting moment, we even hoped to detect Venusian Venus quakes. While no significant seismic activity was detected during its brief operational time, the very fact that we were listening to the pulse of another planet was electrifying. If Venera 13 was the prelude, Venera 14 was the crescendo. This plucky probe didn't just coast through space to Venus, it plunged right into the heart of the unknown. And guess what? It sent back color images too. If you've ever wanted a visual tour of an alien landscape, Venera 14's photos were your VIP ticket. There it was, the rugged, rust-colored terrain of Venus, in panoramic detail. Scientists and space aficionados alike pored over every pixel, every shadow, wondering about the volcanic and geological processes that birthed this landscape. But Venera 14 didn't just stop at eye candy. Oh no, it came equipped with a sophisticated arm designed for soil analysis. With an audacity that would make any geologist green with envy, Venera 14 reached out, grabbed a sample, and analyzed the Venusian soil. The mineralogical data was a goldmine, shedding light on the planet's volcanic past and hinting at its geological activity. It's like being a detective, finding a single strand of hair at a crime scene and unraveling a whole backstory. Now, here's where it gets even more intriguing. Venera 14 had a lens cap on its camera. As it prepared to study the surface, it ejected the lens cap, which, in an unexpected twist of fate, landed precisely where the probe was set to measure the soil's compressibility. It was a cosmic comedy of errors, but being the champs they are, scientists took it in stride, analyzing how the lens cap interacted with the surface, turning a blooper into a boon. Switching gears to Venera 15, the probe that changed our view of Venus. This mission, along with its twin Venera 16, was all about radar mapping. If Venera 14 gave us close-ups, Venera 15 was set to give us wide-angle shots, mapping out vast swaths of Venus's northern hemisphere. And oh, the maps it sent! Using synthetic aperture radar, Venera 15 pierced through Venus's thick, cloudy atmosphere, revealing the topography below in stunning detail. Mountains, valleys, and plains emerged from the data, painting a topographical tapestry of the Venusian landscape. These weren't just maps. They were masterpieces of planetary exploration, helping scientists decode geological processes, volcanic activity, and the erosive forces at play on Venus. Moreover, Venera 15 detected signs of what seemed to be tectonic activity, the plate tectonics of Earth, but on Venus? The very idea had geologists buzzing with excitement. While it didn't provide conclusive proof, it paved the way for further investigation into Venus's geodynamic processes. Mikio Kaku is a renowned physicist, futurist, and author who has a passion for exploring the mysteries of the universe. He is also a fan of the Soviet Union's Nero spacecraft, which were the first to fly by and land on Venus, the hottest and most inhospitable planet in the solar system. He recently shared some declassified photos of Venus taken by the Nero probes on his social media accounts and expressed his admiration and awe for these historic missions. The photos show the harsh and alien landscape of Venus, with its rocky terrain, volcanic features, and thick clouds. The photos also reveal the incredible engineering and scientific achievements of the Soviet space program, which managed to design and operate probes that could withstand the extreme conditions of Venus. The photos also capture the courage and curiosity of humanity, which dared to explore and learn about a world so different from our own. Kaku said that he had been fascinated by the Nero spacecraft since he was a young student and that he followed their progress with great interest. He said that he was amazed by the fact that these probes were able to send back data and images from Venus, despite the enormous challenges and risks involved. He said that he hoped that these photos would inspire more people to appreciate the beauty and wonder of space exploration and to support future missions to Venus and beyond. He also said that he was looking forward to seeing more photos and discoveries from Venus, especially from the upcoming missions planned by NASA, ESA, ISRO, and JAXA. He said that he believed that Venus still had many secrets to reveal, and that he was eager to learn more about its origin, evolution, geology, climate, and potential for life. He said that he hoped that one day, humans would be able to visit Venus in person, using advanced technologies such as airships or floating cities. Michio Kaku concluded his posts by saying he hoped that these photos would remind us of our common humanity and our shared destiny in the cosmos. He said that he hoped that these photos would also encourage us to work together as a global community to protect our own planet Earth, which is our only home in the vastness of space.